This concept is not a description of the history of science. It is a reconstruction of the mechanism of cognition through historical example. Its strength lies not in appealing to the authority of the Greeks, but in the fact that the Hellenic experience is used as an invariant, as a model that is reproduced every time thinking goes beyond the narrative and enters the mode of structure. The Greeks made a leap from empirical observations and practical rules to the search for universal, rational explanations of nature. My Mentis code philosophy asserts that true purification of consciousness begins with the rejection of unverified narratives. In this sense, the Hellenic phenomenon represents the first great cognitive detox of humanity, where other great civilizations, appealing to myths and religious dogmas, reduced natural phenomena to the whims of divine forces, Greek thinkers carried out a radical epistemological shift.
They were the first to consciously formulate the autonomy of nature, physis, seeking immanent, internal, natural factors for natural phenomena. Instead of a ritual answer, they posed a rational question. This transition from a theological to a cosmological conception required the creation of a universal instrument for working with reality. Thus logic, Aristotle, was born as a rigorous, deductive architectonics of thought, capable of organically describing, verifying, and structuring knowledge. Although the Babylonians and Egyptians possessed complex arithmetic and geometry for practical needs, construction, taxation, the Greeks, Pythagoras, Euclid, transformed mathematics into an abstract, deductive system in which truths are logically derived from axioms. The creation of Euclid's Elements became a model of scientific rigor. The Greek breakthrough lay in the understanding that cognition requires two movements simultaneously. The first movement is directed inward, toward essence, toward the principle that organizes a phenomenon. The second movement unfolds outward, toward the multiplicity of forms in which this principle manifests itself. Neither of these movements alone produces knowledge. Abstraction without empiricism becomes an empty play of the mind. Empiricism without abstraction remains a mute heap of facts. What the Greeks called logos meant precisely this dual capacity. Logos lives in things as their inner structure, and at the same time it lives in the mind as the ability to recognize this structure. When Heraclitus said that everything flows according to logos, he pointed to this correspondence. The rationality of the cosmos and the rationality of thought turned out to be isomorphic. That is why mathematics works. That is why classification is possible. That is why prediction is achievable. Hellenic epistemology was born from the awareness that reality has a layered structure. There is the level of immediate experience, where we observe individual events. There is the level of regularity, where events form patterns. There is the level of principle, where patterns are reduced to fundamental relations. Science arises where the mind learns to move between these levels without losing any of them. The systematization of data became possible only after the emergence of the concept of taxonomy. Taxonomy presupposes that a multiplicity of objects can be ordered by identifying common features and differences. But the very idea of a common feature is already an abstraction. When Aristotle groups animals by their mode of respiration, he sees respiration not as a concrete process in a particular organism, but as a function realized through different anatomical structures. This ability to see function through morphology requires a prior theoretical gesture.
Greek science operated at the intersection of necessity and contingency. Mathematical truths are necessary. They cannot be otherwise. Empirical facts are contingent. They could have been different under different conditions. Physics occupies an intermediate position. It seeks necessary relations within a contingent multiplicity of events. The law of falling bodies does not follow from pure logic, but neither is it merely a statement that we observed a stone fall. It asserts an invariant within the variable. The methodology of catalogization gave rise to a new form of memory. Before the Greeks, memory was an accumulation of precedents. After the Greeks, memory became an organized archive where each element occupies a position within a structure. Hipparchus's star catalog made it possible not merely to recall the positions of stars, but to compare states of the sky across different epochs, revealing changes imperceptible within a single generation. Systematization transformed knowledge into a cumulative process, in which each new observation enriches the previous base rather than merely adding to it. What we call objectivity arose from the Greek demand for the independence of knowledge from the knowing subject. A geometric theorem holds regardless of who verifies it. The anatomical structure of a fish remains the same, whether Aristotle observes it or someone else does. This intersubjectivity became the criterion of scientific validity. Knowledge must be reproducible. Anyone with sufficient preparation should obtain the same result. Hellenic thought developed the distinction between doxa and episteme, between opinion and knowledge. Doxa depends on context, on personal experience, on cultural presuppositions. Episteme claims universality. It transcends the local and the particular. But this universality is not given for free.
It requires a method that purifies statements of subjective impurities, tests them for consistency, and correlates them with available data. Greek science created the possibility of dialogue between generations of researchers. Ptolemy could use the data of Hipparchus, although nearly 3 centuries separated them. This continuity became possible due to the standardization of methods and formats of fixation. A coordinate system allowed the transmission of stellar positions without ambiguity. Anatomical terminology ensured unambiguous reference to bodily structures. The logical form of the syllogism guaranteed that an argument would be understood identically by all who knew the rules. The Greek discovery consisted in realizing that reality is amenable to rational reconstruction. Beneath the surface of chaotic events, there exists an order that the mind can grasp and articulate. This order is not imposed upon reality from without. It is extracted from it through consistent analysis. Science becomes a way of reading the structure of the cosmos, where each phenomenon is treated as a text containing information about more general regularities. The Hellenic epistemological stance transformed the human being into an interlocutor of nature. Nature is no longer a mute presence that can only be used. It becomes a source of answers to questions we have learned to pose correctly. Eratosthenes' experiment measuring the Earth was a dialogue with the geometry of space. The catalogization of Theophrastus was a dialogue with the morphology of the living. The observations of Hipparchus were a dialogue with the mechanics of celestial motions. What the Greeks began continues to this day. Modern science has inherited the same duality. It constructs theoretical models and simultaneously gathers vast amounts of data. The Large Hadron Collider combines quantum field theory with petabytes of recorded collisions. The human genome is simultaneously an empirical sequence of nucleotides and a theoretical schema of heredity. Astronomical surveys record billions of objects, while cosmology seeks a single equation describing the evolution of the universe. The Greek intuition proved correct. The cosmos is knowable because it is rational. But rationality does not mean transparency. It means that behind every level of explanation stands a deeper level, which itself is also subject to explanation. Science exists within this infinite movement toward foundations, where every answer generates new questions, and every systematization opens new domains of the unknown. When we speak of the Greek discovery of rationality, we often forget its most astonishing property. Rationality turned out to be a productive error. The Greeks were wrong about almost everything concrete. Their physics was incorrect. Their astronomy was based on a false model. Their biology contained fantastic notions of spontaneous generation, but their method proved indestructible. This is the paradox of scientific progress. Concrete propositions become obsolete, but the procedure by which they are obtained improves. The Ptolemaic system collapsed, but the mathematical apparatus for modeling celestial motions remained. Aristotelian physics died, but the idea of explanation through causes survived all revolutions. Hippocratic humoral theory disappeared, but the clinical methodology of observation became the foundation of medicine. The Greeks invented error as a productive element of cognition. Before them, error was a failure, a catastrophe, a sign of a wrong path. After them, error became a catalyst. If a theory contradicts the facts, the theory must be changed. If observations do not fit the scheme, the observations must be checked or the scheme expanded. Knowledge grows through correction, not through revelation. This stance changed the temporality of cognition. Truth is no longer given immediately and once and for all. It is constructed gradually through successive approximations. Each generation of scientists stands on the shoulders of the previous one, seeing farther, while simultaneously recognizing the incompleteness of its own vision. Scientific tradition lives as a continuous self-correction. The systematization of data produced another effect the Greeks did not anticipate. Large masses of organized information begin to generate questions on their own. When Hipparchus compared star charts separated by centuries, precession became visible. It was not the goal of the research. It emerged from comparison. When Aristotle compiled a catalog of marine organisms, gaps in classification appeared that pointed to the possibility of transitional forms. A database becomes a research instrument. It allows the detection of regularities invisible in individual cases. Statistical patterns emerge only in large datasets. Correlations become noticeable through the comparison of numerous observations.
The Greeks created the infrastructure of future discoveries by organizing knowledge in such a way that it could generate new knowledge. Hellenic thought discovered the recursivity of cognition. Knowledge becomes an object of knowledge. Logic studies the rules of thinking. Methodology examines research procedures. Epistemology analyzes the nature of cognition itself. This capacity for reflection, for turning thought upon itself, proved to be as important as the capacity to think about external objects. The metascience born with the Greeks made it possible to recognize the limits of one's own methods. Euclid understood that geometry rests on axioms that are themselves not proven. Aristotle saw that any chain of justification must end with something unproven. This awareness of a foundation that must be accepted without proof marked the beginning of critical epistemology. Rationality turned out to be more modest than initially assumed. It cannot derive everything from nothing.
It needs initial assumptions, empirical data, intuitive insights. But within these limits, it yields results that work. Geometrical optics allows the prediction of the path of rays. Plant classification allows the identification of a species by its features. Astronomical tables allow the calculation of eclipses. Greek science created a culture of proof. Every claim must be accompanied by argumentation. This argumentation must be public and available for verification. Truth is not the property of the one who utters it. It belongs to the community that has verified it. Knowledge becomes a collective asset that is transmitted, criticized, and refined. The commitment to publicity changed the social organization of knowledge. Schools emerged where students did not merely memorize the teacher's words, but learned to reproduce his reasoning independently. Libraries appeared that stored not sacred texts, but research records. Debates arose where opponents argued not for power, but for the clarification of truth. This communicative structure proved more resilient than any particular theory. Even when Greek civilization fell, scientific communication survived it. Arabs translated Greek texts, continued research, and added their own discoveries. Europeans received this tradition through the Arabs and developed it further. The Chinese, who invented many technologies earlier than others, did not create such a tradition, and therefore their discoveries remained local. The Greek legacy lies not in concrete results, but in the procedure by which they are obtained. This procedure includes posing questions, formulating hypotheses, collecting data, testing hypotheses, correcting errors, systematizing knowledge, and transmitting it to subsequent generations. None of these elements taken separately is unique. Their integration into a single practice is unique. Modern science extends the Greek project.
We search for universal laws behind particular phenomena. We build mathematical models of reality. We systematize data in databases accessible for analysis. We publish results for collective verification. We teach students not facts, but methods for establishing them. The Hellenic intuition proved deeper than the Greeks themselves realized. They discovered that cognition is a process, not a state. Knowledge is never complete. Every answer contains the seeds of new questions. Every systematization reveals gaps that require filling. Every theory will sooner or later encounter facts it cannot explain. This incompleteness is not a weakness of science. It is its strength. Science lives because it leaves room for correction. It does not claim absolute truth, but moves toward ever more precise approximations. This movement is endless because reality turns out to be more complex than any model we can construct.
The Greeks taught us to live productively within this uncertainty. They showed that one can investigate without knowing the final answer. One can build theories while understanding their temporariness. One can systematize data while recognizing their incompleteness. One can transmit knowledge while allowing for its future refutation. Rationality became not a guarantee of truth, but an instrument for its search. It does not promise that we will reach the end. It promises that each step will be justified, each error recognized, each discovery recorded. In this sense, Greek science remains relevant not despite its errors, but thanks to the method of their correction. These thoughts arise at a moment when the intellect realizes its own vulnerability to the chaos of information. They were born not from a desire to retell a textbook, but from the need to find a foothold in an era where the quantity of data negates its quality. It is an attempt to justify the human desire for order.